This section of notes is Chapter 16.1, Introduction to Relations. The concepts we're going to go over here are the definition of a relation, domain and range of a relation, and applications involving relations. So concept 1, the definition of a relation. So see here we have a table. This table is showing the relationship between the length of femurs and the height of an individual. We can take the data on this table and turn it into a point. So for example, the first information on this table, we have a 45.5 centimeter femur in relation to a 65.5 inch height. So how this is written is x comma y. So each of these points on the table can be written as an ordered pair x comma y. And these are the relations. Looking at concept 2, we have the domain and range of a relation. A set of ordered pairs x and y is called a relation in x and y. Furthermore, the set of the first components in the ordered pair is called the domain of the relation, and the set of the second components in the ordered pair is called the range of the relation. So all this is saying is that the x's are the domain and the y's are the range. That's all this definition is saying here. So if we look at some examples, notice in this first example here, we just have a set of ordered pairs. Okay, so it's just a bunch of coordinate points x comma y. So we know that all of the first numbers are x. So here are all my first numbers, all of my x's, okay? And that all of my second numbers are my y's. So if we were to write the domain and range of this set, the domain would be all the x's. So I'm going to write all these x points in the curly brackets. So 45.5, 48.2, 41.8, 46.0, and 50.4 curly brackets. And then the range are all the y values, so the ones that I highlighted in blue. So again, writing these in the curly brackets, I have 65.5, 68.0, 62.2, 66.0, and 70.0 in the curly brackets. Okay. So for example 2, we're going to do the same thing because we have another set of coordinate points, set of points, x comma y. So first we're going to look at all of the first values because those are our x's. So we have 0, -8, 1/2, -3, and notice how we have a second -8. Okay. When we're writing the domain and range, we do not need to repeat numbers. So since we already highlighted a -8, I'm going to go ahead and not highlight that second -8. So if I'm writing my domain, the only numbers I'm writing are 0, -8, 1/2, -3 in the curly brackets. Okay. Again, I do not write repeated numbers. Okay, that's why there's not a second -8 here. Same thing looking at my range, I have 0, 4, 1. Okay, again, see how I have a 4 that has already been said? I'm not going to highlight it. And then lastly, this 0 has also been repeated because we highlighted that in the beginning, so I'm not going to highlight that again. So everything I highlighted in blue is my y, so that is my range. So I have curly bracket 0, 4, 1. Close curly bracket. Okay. Now instead of having a set of points, in example 3 I have a table. Notice in my first column of the table, my x's, Instead of having numbers, I now have that represented by states. Okay? We're still able to take this table and write this as an ordered pair. So I'm still going to write this as X, comma, Y. So looking at the first row, I have Alabama and I have 7. So that means my point is going to be Alabama, comma, 7. Okay. Writing my next point, I have California, comma, 53, because that's in the same row. Next, Colorado, comma, 7. Florida, comma, 27. And lastly, Kansas, comma, 4. So now I have this all written as points. I'm able to see my X's and my Y's, just like we did in example 1 and 2. So looking at all my X's, notice that all of these are the states. So Alabama, California, Colorado, Florida, and Kansas. So when I'm writing my domain, I'm just going to be writing out all of those states in the curly brackets. So I have Alabama, California, Colorado, Florida, and Kansas. Okay. Now looking at my range, I know that those are all my Y values. So I have a 7, a 53. I've already highlighted a 7, so I'm not going to highlight it again. 27, 4. So that means my range is 7, 53, 27, 4. Okay, looking at number 4, again we have a table where we have our X's in the first column and our Y's in the second column. So we could go ahead and put these into points. We could write the coordinate point bear, comma, 22.5, cat, comma, 11, so on and so forth. But since our table is already separated in X and in Y, we could go ahead and highlight what our domain and ranges are going to be. So our domain are all these animals. So as long as they don't repeat, they're going to be in our domain. So bear, cat, cow, deer, dog, elephant. And then again with our range, we are only going to highlight the numbers that don't repeat. So we have 22.5, 11, 20.5, 12.5. I'm not going to highlight that second 11 because I already have an 11 in my range. And then 35. So if I was writing my domain, it would be all these animals. So bear, cat, cow, deer, dog, and then elephant. And then my range, 22.5, 11, 20.5, 12.5, and 35. Okay, so that's how you would write the domain and range for example 3 and 4, because they're in tables. Now looking at example 5, we're going to look at maps. So notice that in that first oval to the left, that is representing our X's. So our X values here are 3, 2, and -7. And then in that second oval, that is representing our Y's. So first what we're going to do from this map is we are going to turn this map into ordered points. Notice these arrows coming off the X value. Since there are 3 arrows coming off the X value, that X oval, that tells us that there's going to be 3 points. And those points are going to be 3, -9, 2, -9, -7, -9. Notice that all of my Y terms were -9 because all of my X terms were pointing to that same number. So if I was to look at my domain, I have 3, 2, -7. And then looking at my range, since all of them are -9s, I'm just going to highlight 1. So my domain, 3, 2, -7. My range, negative 9. Okay. Looking at example 5, I have another map. Remember, the first one is x, the second one is y, and then counting the arrows coming off the x, I have 4 arrows, so it's going to tell us that we have 4 points. So my points are going to be negative 5, 0, 2, 8, 2, 15, because there are 2 arrows coming off that number 2, and then 4, 16. So if I was to highlight my x's, I have negative 5, 2. I'm not going to highlight that second 2, and then 4. And then with my ranges, I have 0, 8, 15, 16. None of them repeat, so I'm highlighting them all. So that means for my domain, I have negative 5, 2, 4. And my range, 0, 8, 15, 16. Okay. Now on to the next example. We have a coordinate graph where we have all of our points plotted on this graph. So since all of these points are not labeled, I'm going to go ahead and do that first. So I'm just going to label them A, B, C, D, E. And then I'm going to use these labels so you're understanding which point I am labeling as the ordered pair. So looking at A, this ordered pair would be negative 2, negative 3, because I'm looking at the x's and then looking at the y's. B would be negative 1, 0. C would be 0, 1. D would be 1, 0. And lastly, E would be 2, negative 3. Now that I have all of those points, I'm going to go ahead and highlight all my x values, my domain. So I have negative 2, negative 1, 0, 1, 2. None of those numbers are repeating, so that is my domain. So negative 2, negative 1, 0, 1, 2. Now looking at my range, I have negative 3, 0, 1. And then notice that I have that 0 repeated and a negative 3 repeated. So I'm not going to write those. I'm just going to write the first ones that come up. So negative 3, 0, 1. Okay, same thing for number 8. So I'm first going to label everything. So A, B, C, D, E. So for my A, that ordered pair, that point is going to be negative 4, 1. B is going to be 0, 2. C is going to be 1, negative 3. D is going to be 4, 4. And lastly, E is going to be 4, negative 5. Again, remember I'm looking at the x values, then I'm looking at the y values. So first, looking at my x values, I have negative 4, 0, 1, 4, and since that second 4 repeats, I'm not going to highlight it. And then for my y's, I have 1, 2, negative 3, 4, negative 5. None of them repeat, so that is going to be all those numbers included in our range. So for our domain, we have negative 4, 0, 1, 4. And then our range, 1, 2, negative 3, 4, negative 5. Okay, so that was example 7 and 8 using the graphs. Now looking at number 9 and number 10, notice that we have a physical graph here. So in number 9, we have a graph of an ellipse. And when we're finding the domain and range of these ones, we are going to be using those brackets and those parentheses that we did in the previous notes when we were talking about interval notation. Okay, since this ellipse is a solid line, we are going to be using only brackets with our domain and range. Okay, so first looking at our domain, we know domain is our x's. So we are looking left to right. So how far left does this graph go? In this case, -8. And how far right does this graph go? In this case, +8. So if we were to write this as a domain, it would be -8, 8 in brackets. Same with the range. Now we're looking at the y, so we're going to how low does this ellipse go? In this case, -5. And how high does this ellipse go? In this case, +5. So we would write -5, comma, +5 in the brackets. Okay. Notice when we're writing our domain and ranges, we go negative to positive. So it's always the negative number first, then the positive. Or in other cases, it could be the lowest number, then the highest number. Okay, so same thing for number 10. Number 10, we have a circle. And since this circle is a solid line and not dotted, we are going to be using brackets. So again, looking at the domain, how far left does it go? -4. How far to the right? 0. So our domain would be -4, comma, 0. With our range, how far on the bottom does it go? So -2. How far going towards the top? +2. So we have our range of -2, +2, both in those brackets. Okay. Now looking at number 11, we have another graph. It has some solid lines on there, but notice we have this arrow. This arrow tells us that we're going to be using some type of infinity. And with that, when using any type of infinities, that means in our domain or in our range, we're going to include parentheses. Okay? So if we see the arrow, this means parentheses. Also, if we see that open dot, that means parentheses. Okay? So first, looking at the domain, we're going to see how far to the left this goes. So as far to the left, this goes to 0. Then we look at how far to the right does this go. Since this arrow here keeps going over to the right, that means there's no stopping point here on where it's going to end on the domain. So if it's going to continue going to the right, then it's going to continue going to positive infinity. So if we were to write our domain, we would do bracket 0 because of that solid line of the graph on the 0, comma, infinity with a parenthesis. So that is our domain. Now looking at our range, we're going to see how low this graph goes. So this graph goes as low as -2. But since that -2 has that open circle, that open dot, we're going to be using a parenthesis on that -2. Now looking how high this graph goes, we also have to focus on this arrow. So even though this arrow is going all the way to the right, as it goes to the right, it's also going higher, meaning we cannot stop the range on the highest point, meaning our range is going to go to infinity. Same for number 12. Okay. Number 12, first we're going to look at the domain. So on the domain, we're first looking how far to the left can this graph go. Well, notice if we go all the way to the left, we have arrows on either side. That tells us that graph is going to continue going on forever and ever in that left direction. So that means our domain is going to start negative infinity, and then looking how far to the right it goes, notice that it stops at 0. And since at that 0 point there is a solid line, we are going to have 0 with a bracket. So that's the domain. Now looking at the range, we're looking how far low does it go and how far high does it go. Notice we can't stop the height of this graph going in either direction because this arrow tells us it's going to keep going down in the negatives, and this arrow tells us it's going to keep going up in the positives. So that means that our answer here for range is going to be negative infinity to positive infinity. Another way to express that is saying all real numbers, which is represented as a fancy R. Okay, last concept is applications involving relations. So in these applications, we're using these real-world problems, and that's going to show us how we're going to involve the relation, so either the points or the domain and range. So looking at example 1, it says the data below depicts the length of a woman's femur and her height. Based on this data, forensic specialists found a linear relation between the height y and the femur x. The relation is given by y is equal to 0.91x plus 24, and the range for the domain for these x's are 40 is less than or equal to x, less than or equal to 55. So here it gives us the table. Notice this table is the same table that we used in the beginning to illustrate what a relation was. So we're going to be using this table to be answering the following questions. So for part A, it says find the height of a woman whose femur is 46.0 centimeters. So first thing, before we go back and use the relation, remember the relation is up here, we need to check our table. Can we find 46.0 centimeters on our table? We can. That 46.0 centimeters is right here, and it tells us that the height is 66 inches. So we would just write that. So the height is 66 inches. Okay, now looking at part B. Part B says find the height of a woman whose femur is 51 centimeters. So we have 51 centimeters. Let's look back at our table. Notice that our table only goes to that 50.4. So that means we're going to have to plug in that 51 centimeters into our problem. Okay, so plugging into our problem, our relation of y is equal to 0.91x plus 24. This 51 centimeters is our x value. So we have y is equal to 0.91 times 51 plus 24. If we type that out into our calculator, we get y is equal to 70.41 inches. And that is our answer. Okay. Last question, it says, why is the domain restricted to 40 less than or equal to x, less than or equal to 55? So when we're talking about this restriction, since we're talking about a real life problem where these scientists had all this data below and they were able to find a linear relation, there are many reasons why they could have restricted that domain. So one of the reasons is they could have restricted that domain because if they are trying to fit the linear function on a graph, they want that graph to be restricted from 40 to 55. Or let's just say that out of all the data that they found, let's say that the shortest femur they found was 40 centimeters, and the largest femur they found was 55 centimeters. So why include other numbers in that domain if all our data is within those numbers? So that's why they made the domain that way. So we would say that based on the data, they found that the smallest femur was 40 centimeters and the largest 55 centimeters. Okay, again, we're just taking the knowledge that we know and interpreting that domain. Okay, last example here, number 2. It says the following linear equations relates the weight of a car in pounds X to its gas mileage in miles per gallon Y. So it gives us the relation Y is equal to negative 0.014x plus 64.5. And then it gives us the domain 1500 less than or equal to X less than or equal to 4000. So in this case, we don't have a table that we can check our data on. We're going to be only using that equation. So for A, it says find the gas mileage in miles per gallon for a car weighing 2,550 pounds. Okay, so pounds up here we know is our X value, and miles per gallon our Y value, meaning that this 2,550 is going to be our X. So we're going to plug that in. So Y is equal to negative 0.014x plus 64.5. Instead of X, we're going to be placing that 2,550. And then plugging that all into our calculator, we get Y is equal to 28.8 miles per gallon. Okay, same with part B. It says find the gas mileage for a car weighing 2,850 pounds. So again, now we're plugging in this value for X. So I have Y is equal to negative 0.014x plus 64.5. Be plugging in that value for X. And then when I plug this into my calculator, I'm going to get Y is equal to 24.6 miles per gallon. And then lastly, it says, why is the domain restricted to 1,500 and 4,000? So we could say, again, multiple things about this. We could say that the data that was used to create this relation, the lightest car they had was 1,500 pounds and the heaviest 4,000. So that's what we're going to go ahead and do. So we're basing off the data that we have. So based off the data, the lightest car was 1,500 pounds and the heaviest 4,000 pounds. Again, I'm not saying that in the entire world the lightest car is 1,500 and in the entire world the heaviest car is 4,000. That is only based off of this problem with the data that they used to create this relation. And that concludes the notes for 16.1. If you have any questions, please reach out to me.